Next, let's go on to counting principles that involve multiplying. All right. So there are two basic ways to select multiple things, and that is either with repetition allowed or without. We've already alluded to this a little bit with the cards in the deck. At the bottom of your handout, the counting principles page, it says how many California license plates can be made of the form number, letter, 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 number, number, number. That's the default for your California license plate. So it has 7 characters in it. So we're going to draw 7 blanks to be filled in. 1, 2, 3, 4, 5, 6, 7. And we require that the first character is a number, a digit, in other words. How many digits are there to choose from? There are 10. Because you've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. 10 digits to choose from. The next character has to be a letter, a capital letter. How many capital letters are there to choose from? There are 26. The third character also has to be a letter. Is it allowed to be the same letter as this one? Yes, it is. So it's basically just like we replaced the letter. We picked a letter, like let's say the letter B, and then we kind of put it back into the alphabet. So that when we pick the third character, we're choosing from the full alphabet again. So once again, 26 choices. And again, the fourth character, also a letter, but it can be a repetition, so there are 26 to choose from. The next character has to be a digit. Is it allowed to be the same digit as this one? Yes. We're choosing from all 10 digits again, and again, and again. Now, what do we put in between all those numbers? Again, we need to think about the words and, or, and not. We want the first character to be a digit, and the second character to be a letter, and. So these are all multiplied together, and means times. That's a big number. I guess I'll just choose to write it as 10 to the 4th times 26 cubed. So when we do selections with repetition, we usually end up with exponents in our answers. So let's contrast that with selection without repetition. Again, we're choosing a California license plate, digit, capital letter, capital letter, capital letter, digit, digit, digit. But this time there's a new rule. No repetitions are allowed. How many choices are there for the first character? It has to be a digit. There are 10 digits. And the second character has to be a capital letter. There are 26 of those. And the third character has to be a capital letter, but it's not allowed to be the same letter as this one. So if we pick the letter B, let's just say that this one is an 8 and this one is a B. This one cannot be a B, so we're picking from a subset of the alphabet that only has 25 letters left in it. Let's say that we choose a P. So this character can be any capital letter except B or P, so there are 24 of them. Let's just say it's a Z. Now we have to choose another digit. Let's suppose it's not allowed to be an 8. How many digits are left? 9. Let's suppose it's a 6. The next character also has to be a digit, but it cannot be an 8 or a 6. There are only 8 left. Let's just say it's a 5. Finally, the last character also has to be a digit, but it's not allowed to be an 8, 6, or 5, so there are only 7 left to choose from. Let's just say it's a 1. Okay, so this is an example of a license plate, and this counts the number of ways to create it. So this time we don't end up with powers because these numbers are not repeated. But again, we see descending integers. 26, 25, 24. If we put them in order. 10, 9, 8, 7. So that's kind of a sign that we're selecting without repetition. We get descending integers. All right, if you look at the top of the next page of your handout, where it says combinatorics, it says multiplying descending integers is the basic counting principle behind combinatorics, or counting the number of ways to make selections without repetition. So In the next video, we're going to start getting into more detail about combinatorics. There are three essential counting principles that are called combinatorics. They are the factorial, the permutation, and the combination. Before we get there, I just want to recap the difference between a set and a sequence, because those are going to be major issues in this topic. Alright, so the example that I use to discuss sets and sequences is grocery shopping. So let's suppose that you're in the grocery store and you have a grocery bag with 4 items in it. You've got eggs, cheese, milk, and bread. And you kind of shake this bag up a little bit, maybe drop it on the floor, pick it up again, and the items are all reshuffled in there and probably broken by now. Now they're scrambled in a different way. But that's still the same set of groceries. It doesn't really matter exactly how they're arranged in the bag. They're still the same set. And the way we represent a set in math class is we use curly braces and commas. So the set of BCEM is the same as the set EMCB, which is the same as the set MECB. In other words, the order doesn't matter. You can scramble up a set all you want, it's still the same set. It's only counted once. Now, when you're done shopping, you go up to the register and you have to put your items on a conveyor belt. And they have to get rung up in a particular order. So maybe you put your bread first and your cheese second and your eggs third and your milk fourth. They would get scanned first, second, third, fourth. So they would be scanned in a different order if you set them up in the sequence CMEB. So in other words, in a sequence is all about the order. It's not only about the items in the set, but also what order they come in. So we usually represent that by drawing blanks without commas in between them, but often numbered underneath, first, second, third, fourth, etc. So I'm sure you can see here that from each set, for every one set, can produce many sequences. So that distinction needs to be clear before we move on with the combinatorics lecture.